RHS Pre-Calculus presents A Day at the Fair, Linear and Angular Velocity. Our goal is to show the conversion of angular to linear velocity. Linear velocity is defined as a measure of how fast a point moves along a circular arc, or arc length over time. Linear velocity is typically measured in miles per hour, inches per second, etc. Angular velocity is the measure of how fast the angle changes. It's typically measured in revolutions per minute, degrees per minute, or radians per second. At the Evergreen State Fair, one of the most popular rides is the carousel. Little Timmy Turner gets on the carousel and gets off after a few minutes. When he steps off, he finds himself to be very dizzy. The carousel was rotating at 2 revolutions per minute, but Timmy wants to know what his angular velocity was in radians per second, and his linear velocity in feet per second. Cosmo and Wanda came to help. Cosmo says, "To begin, record all the information given in the problem. In this case, you know the carousel travels at 2 revolutions per minute and has a diameter of 20 feet, or a radius of 10 feet. First, set your angular velocity at 2 revolutions over 1 minute. Since we want to find Timmy's speed in seconds, first we should convert to minutes into seconds. To do this, multiply 2 revolutions over 1 minute by 1 minute over 60 seconds. This way, the minutes will cancel, leaving only 60 seconds in the denominator. Next, the revolutions must be converted to radians, so multiply the 2 revolutions over 60 seconds by 2 pi radians over 1 revolution. This results in 4 pi radians over 60 seconds, which can then be reduced to pi radians over 15 seconds. This is the angular velocity in radians per second." Wanda adds, "To find the linear velocity, pi radians over 15 seconds must be converted to feet per second. To do this, multiply it by 1 revolution over 2 pi radians. This will cancel the radians. Next, to cancel the revolutions, multiply it by their circumference over 1 revolution. The equation to find their circumference is 2 pi times the radius, so here it is 20 pi. When multiplied together, the result is found to be 20 pi over 30 seconds. This can be reduced to 2 pi over 3 feet per second. This is the linear velocity." "Thanks, Cosmo and Wanda," said Timmy. "I understand linear and angular velocity now. But that took so long. I still want time to play with Chester and AJ. I wish there were a shorter way for me to solve the problem." "We don't need one for this one, Timmy," said Wanda. "There's a shortcut to finding the linear velocity without going through lots of conversions. You can just multiply the angular velocity by the radius to find the linear velocity." "In this problem," said Cosmo, "we found the angular velocity to be pi radians over 15 seconds. We know the radius of the carousel is 10 feet, so you can multiply the angular velocity pi over 15 by 10, which leaves you with 10 pi over 15. This reduces to 2 pi over 3, which we found to be the linear velocity." "That is a lot easier," said Timmy. "Why didn't you tell me that in the first place?" "It's not our fault," argued Wanda. Dingleberg.